record share. Okay, our today's lecture will be first lab, designing a 4-bit adder to successfully use a user symbol in the schematic to construct a 4-bit adder to check the functionality of the design using simulation with built-in simulator. That means we already built the user symbol of full adder, right? Full adder. We already built that. What was that? This one, actually. We already built that, right? And we know how it works. Now today we will be using this symbol to make our 4-bit adder. That means bigger one. The designing a 4-bit adder. Now here, at first we have to see how the addition works. Let's say you have two words, two numbers. One is A, another one is B. What is A? A3, A2, A1 and A0. What is B? B3, B2, B1 and B0. These are actually bits, like 1101 or 1111 or 1001. This number, they're actually numbers. Okay. Now let's say you have two numbers. One is this one, another one is this one. So let's add. At first, you will add with the LSB. That means the least significant bit, or the bit at the right side. So A0 and B0. If you add them, your result will be S0, and your carry will be C0. Carry means you might have something in your hand. Okay, wait. That means you might have something in your hand after the addition. The addition result is the sum, and whatever you have in your hand, that is your carry or output carry. So this output carry will go to the input of the next bit. So A1, B1, and that is your C0. Got my point? So this output carry will go to the next bit as input. Now look here. So C0, A1 plus B1, your result is S1. You might have another carry out in your hand. So that will go, okay, someone is asking something. Who said you start first? Abdiaziz? No problem.
Yes, sir.
Okay, no problem, carry on. Okay, you'll understand what I am saying.
Okay. Okay, okay, I will try to understand, sir.
Okay, you will understand, no problem. Now see this one. So you have two numbers. Your A is there, and you have a B. Wait. Abdiaziz, I'm making you co-host. You accept others when they come. Now again, you have two numbers, A and B. So A0 plus B0, your result is A0. You might have something in your hand, that is your C0, the carry, that will go to the input of the next bit. So C0 plus A1 plus B1, your result is S1. You might have something in your hand, that is called C1. This C1 will go to the next bit. That means here. So C1 plus A2 plus B2, your result is S2. Then you might have something in your hand that will go to the next bit here. So C2 plus A3 plus B3, your result is S3. Again, you might have something in your hand that is C3 that will go to the next bit and that will sit directly in front of your result. So your final result is this one, C3, S3, S2, S1 and S0. These are your final result. So here you can see at the first bit, that means here, A0 and B0. A0 and B0, you do not need anything at the front, right? So you only have two numbers, that means two bits, A0 and B0. So you can use a half adder there, half adder has only two inputs, A plus B. You can use a half adder there, or you can use a full adder there and mute one of your input or one of the input, or make the one of the input 0. Okay, we will be using full adder, not half adder, because we have a plan for the future. So we will be using a full adder there. So one full adder, two full adder, three full adder, four full adder. So we need four full adder. Let's design it. Okay, I have the design procedure here. I already designed that. Let's design that. Okay, let's make it. Now let's go to the DSCH. I have my DSCH here. Okay, can you see this? I believe you can see this, right? Okay. Now share screen. This is my DSCH. Now I will be inserting my previously made user symbol. That symbol I made in the first lab. Now insert. I'll go to the user symbol. Now this is the D25FA. D25FA. So I'm going to click that. I'll click open. That is the symbol we made actually in the last lab class. So we will be using that, and I want to make a copy. Okay, why is the copy? Here you have a copy. Here this is a copy. So copy button. I will click the copy. So I will click it, and I will make a copy like this. Then I will click it, and I will make another copy. So I need 4 full adder, right? Because I have 4 bits. So 4 full adder. So next copy. Way too much. Okay. Now click all. This is my symbol. So 1, 2, okay. 1, 2, 3, 4. So 4 of them are there. So I need A and B. So A means your A means A1, A2, A0, A1, A2, A3, right? 4 buttons. I want to use 4 buttons here. So I will click 4 buttons. I will bring 4 buttons. This is 1 button. 1, 2, 3, and 4. So 4 buttons are here. So first one is this one. Let's call it A3. Then A2. Then A1. Then A0. So 4 of them are here. So I want to make a copy. So I want to make a copy of this one. So this is my copy. So I will select everything. and I will make a copy. So for B actually, this is for B. So I will double click and I will write the name B. I will double click and write the name B. Double click, write the name B. Double click, name B. So B1, first one, B0. Okay. A2, A1, A0, A3, A2, A1, A0, B3, B2, B1, B0. So 4 inputs are there. So I need LEDs. So 1, why LED? Because we have S0, S1, S2, S3, and C3. That means we will have 5 bits of output. 5 bits of output. So we need 5 LEDs. 1, 2, 3, 4, and this one, let's say this is separated because there is C. So let's call it S0. Next one is S1. Next one will be S2. Next one will be S3. And the last one, you can call it S4. You can call it S4 or you can call it C3 or whatever. I am going to call it S4 because sum. Okay. Now let's connect. This A3 will go at the top. Next A will go to the next A. Next A will go to the next A. That means here. Next A will go to the next A. So this is the LSB or least significant addition here. So A0, B0. This is A1, B1. This is A2, B2. This is A3, B3. Okay, that's why I make the naming like that. Now here, last B3, the B3 will go at the top because that is our B3, A3 addition. Now the B2 will be here. Now the B1, next B0. Okay. Now remember you have a C0 here, right? Here you have a C. That means this one. Do we need this? We do not need this because we do not have anything here. At this place, we do not have anything. That means when you start the addition, there is nothing in your hand. So this place is not used. So this C button will not be used because we have only 2 input, A and B, A0 and B0. We do not have anything. So let's use a ground. This is our ground. Let's use a ground to make it grounded. That means it is not used. This is important. You have to ground the unnecessary pins. Remember, you have to ground the unnecessary pins that you are not using. So you have one S and one CO. Your S is your result. You have seen that here. Your S is your result. Whatever you have in your hand, that will go in the next bit. So your S is your result. This is your result. So this S is your S0. Directly go to the result. This C0 will go to the next input carry. See, this C0 go to the next input. This S is your another output, S1. So here you have what? You have A1, you have B1, and you have C0. So A1, B1, and C0, right? That will give you S1. That S1 is gone. Now you have one C1. This C1 will go to the next input. So here you have A2, B2, and C1. The result will go to the S2. You have another carry out. This carry out will go and join here. This is your S3. Now you have one more. Okay, somebody wants to join. Now, so we have one more output, that is CO. Where the CO will go? Remember, your C3, actually not CO, actually your C3 will go to the next place or at the MSB of your result, MSB. So this one will directly go to the first LED. So let's take that. Like this. So let's what is that? Let's check whether our design is okay or not. So no gray line, so everything is blue. You can see here. Let's click 1 1 1 1 and 1 0 0 1. So your final result is 1 plus 1 plus, see here you have 1 1 1 1 plus 1 0 0 1. So your result will be 1 1 0 0 0. Are you okay? Now see this one. 1 1 1 1 means F, right? This is F. Okay. Let's bring it and check whether our result is okay or not. See, I need to change the mode to base. So you need to click binary. So 1 1 1 1 plus 1 0 0 1. Whether your result is okay or not. See your result 1 1 0 0 0. So your result is okay. That means we are successful in making a full adder, 4-bit full adder, right? Now I want to change something here. I want to make something more beautiful. I want to change it and I want to make it more beautiful. How can I do that? Okay, let's get rid of these LEDs. Get rid of these LEDs and use these, what is that? Use this Hexa display or digit. I need one, I need another one. Oh. Okay, you have, okay, that what I have done. Now here, see, this is gray, right? This is red, this is gray, because I told you before, if you have some unused pin, these pins are unused. If you have some unused pin, you have to make them grounded. Now let's use take a ground and connect them together, because I am not going to use them, right? So all three of them will be grounded. Now this will be red and red, no problem. Now again, the simulation 1 1 1 1 and 1 0 0 1, that is 1 8. So take the previous example and convert it to hex. See, your result is 1 8 hexa. Your result is in now hexadecimal. You can see your result in hexadecimal, right? Okay. Now change the input pins. Why this is necessary? Because this will be necessary for our next labs. So when we'll be dealing with bigger numbers, so it will give us some what is that comfort. Now let's bring it. This is a hexa display, hexa input. This is an hexa display. This is an hexa input. So I will connect it and double click. See, there is a key, red color key. So you have to unclick it, change the name, and you have some what is that? The names, right? Click symbol title, pin names. Double click again, pin names. See, your name is automatically changed. So A3, A2, A1, A0, B3, B2, B1, and B0, right? Your name automatically changed.
Yeah.
Okay. Now bring another one. Double click. There, if there is a key there, change the key. B. This will be B. Click pin names. Okay. Double click. Okay. Double click again. Click OK again. So it will automatically change the names. So you do not have to change everything, right? So previously you have seen I used four buttons for A and for B, and I had to change everything manually. Now it is automatically. Now what is the benefit of this one? See, when I click run, when I click F, directly it is 1111. When I click 9, that means it is 1001, and the result is 18. So you have F plus 9. It is now hexa. So if you have F, what is F? This is F plus 9, right? F plus 9. Your result will be 18. See, your result is 18. So let's try again. Let's give F plus D. So if you have F plus D, your result should be 1C. Let's see. See, your result is 1C. This is 1, this is C. This is your result. Understood, everyone? Understood, everyone? Okay, I'm going to unmute yourself.
Yes, sir.
You understood? You understood? All of you? Yeah? Abdulaziz? Okay. I'm going to mute yourself again. If you need to say anything, you can ask me, or you can say whatever. I'm going to share my screen again. Now this one is necessary. Remember, this one is necessary because we want to use these later for modification. We will make this one as a what is that? Adder subtractor. That means that can do addition and subtraction both. Okay. So I'm going to save these as an adder. So let's D25 ADD adder. Okay, or ADD here adder. D25 adder. I'm going to save these not as a symbol. Remember, not as a symbol, as a schematic file. I want to save it because I want to use it again in the next labs. We have lab number 9, lab number 11. There we will be using these. Okay. Here you can see the schematic diagram with hex input and hex output. And one thing, I want you to see this. I want to change the button, or I want to change the digits, or I want to change this display. I can use a bigger display. There are two displays here, one here, another one is here, right? I can go to the advanced menu and I can click this 8-bit display at a time. This is 8-bit display. What 8-bit display does? 8-bit display is actually a better display. Wait a minute. Okay, I'm back. Now see, this big display is very useful for our case. I want to use it. Okay. So I use 5 of the pins and 3 of the pins will be grounded. Now, what is the benefit of these? You will see the result directly. Okay, no separate displays. So here F plus 9, your result is 1.8. So what is the benefit of this display? Remember, your benefit of this display is double click, and here you have a format, right? Hexadecimal unsigned integer. If you click this unsigned integer, you can see these in 15. That means not F. Remember, this is 15, not F. 15 plus 9. That means your result was supposed to be 1.8, but it is 24. So F plus 8, your result is 1.8. No, F plus 9 actually. F plus 9, your result is 1.8, right? But if you see these in decimal, your result will be 24. So this display can show you result in decimal as well, decimal. So if you add 8 plus 9, your result will be 17. 8 plus 9, your result will be 17, remember. So this is a decimal display as well. You can see this in hexadecimal, and you can see this in, what is that? Decimal as well. So that is the benefit of this, okay? I'm going to stop the record.